Okay, so question 5. It says calculate the file size in bits. In bits. This is important. Of a 2-minute sound recording that has a sample rate of 1000 hertz and a sample resolution of 5 bits. Okay, now how do we do that? Well, it's in your notes. Let's just show you where that is. We're talking about sound. So let's go to our notes and find a sound. Here we are. And if you look through, there is your formula. Okay, so I'm going to copy that. I'm going to copy that into, you can't do that, of course, but that's what you need to write out in your exam paper. So let's go back to our paper and we're going to write that out. So put that up there. Can I do that? Hopefully. Come on. Okay, can't put that in there, so what I'll do is I'll move that up to the side here. If I can. Oh, sorry, let's change the size of it. I'll move that up there. So you're in your exam, and that's what you should write. Okay, size, and if you wanted to, in bits, is equal to samples per second times bits per sample times length in seconds. Okay, so let's see what we've got here. Samples per second. Well, that's the rate. This is the sample rate. So another word for that is the sample rate. And what is the sample rate? That's 1000. Okay, times bits per sample. That's the sample resolution, that bit. So sample resolution. So that's 5. Multiplied by the length in seconds. Well, we've got 2 minutes, so you must convert that to seconds. So that's 120 seconds. So our answer now is 1000 times 5 times 120. So that's 5000 times 120. Well, 120 times 5, let's do that first. 5 noughts are 0, 2 5s are 10, 0 carry 1, 5 is 5, 6. Times that by 1000, so we've got 600 times 1000, add 3 noughts. 600,000 bits. Remember, in your exam, you could be asked to do this in bytes, or even perhaps kilobytes. If it's in bytes, you divide by 8, sorry. So this is not in the question. But if it was, 600,000 bits is 600,000 divided by 8 bytes, if you were asked that, or if it was in kilobytes, perhaps this would be 600,000 divided by 8,000 kilobytes. Okay, and then we can cancel down some zeros, and we get 600 divided by 8, which is 300 divided by 4, which is 150. 150 kilobytes, if you wanted it that. Anyway, you're asked just to leave it in bits, which is fine. Part 2. Another sound file has 24,000 bits. What is 24,000 bits in kilobytes? Here we go. So we've got 24,000 bits. So first of all, we go into bytes. So that's 24,000 divided by 8. And then into kilobytes, we divide by another 1,000. So we've got 8,000 here. So we've got 24,000 divided by 8,000. We can cancel some zeros. And 24 divided by 8 is 3. So our answer is 3 kilobytes. Part 3. Sound files are recorded as bit patterns. Bit patterns are often compressed. Compress the following bit pattern using run length encoding. So let's just remind you of what run length encoding does. It goes through bits that are the same value and it creates a count of how many there are, and then lists that count with the character itself. So here we've got 6 zeros. So this is going to be 6 zeros. Then we've got 1, 2, 3, 4, 5, 6, 7 ones, followed by 1, 2, 3, 7, 8, 9, 10, 11, 12 zeros, followed by 1, 2, 3, 4, 5, 6, 7 ones. So our answer is 6 zeros, 7 ones, 12 zeros, 7 ones. Now the only problem here is that we don't 100% certain know, if we didn't put the commas in, whether we must put commas in there, because if we put 6 zeros followed by 7 ones followed by 12 zeros followed by 7 ones, we don't know whether that's 607 ones followed by 1,207 ones. We don't know that.